Hey, you're here with Mrs. Mays. Welcome back to AP Chemistry. Today we're going to look at measuring with solutions. So let's start thinking about molarity. Measuring with solutions is how we determine the concentration. In other words, we're going to describe how much stuff is dissolved. We usually use molarity here, where we describe the moles of the solute dissolved in a certain number of liters of solution. We use a capital M for molarity, and 1 molar means 1 mole of solute is dissolved in 1 liter of solution. So let's look at an example. We'll do a calculation. We want to calculate the molarity of a solution with 34.6 grams of sodium chloride dissolved in 125 milliliters of solution. So my first step is to figure out how many moles we've got. If there are 34.6 grams of sodium chloride, then how many moles would that be? Remember how to turn grams into moles? Right? Crisscross to cancel. So I'm going to put grams on the bottom and moles on the top. In every 1 mole of sodium chloride, there's 58.5 grams. 1 sodium plus 1 chlorine. So now I multiply the top times the top, and I divide by the bottom. Get your calculator out and check my math, because there's a chance that I could make a mistake. I got 0.59 moles. But I'm not done answering the question yet. I need the molarity, so I need moles per liter. So I take my moles divided by the liters. I was given 125 milliliters. To convert milliliters to liters, I need to move my decimal over 3 times. And you're going to get so good at that you can do that in your head. So we have 0.125 liters total. And now I can't do this math in my head. It's time for a calculator. So you get your calculator. I'll get mine. Ready? Okay, so it's 0.59 divided by 0.125. That's it. 4.72 molar. So we write 4.72 big M and then put your label on it, NaCl. Put a box around your answer because that's the way I like it. All right, so far so good. So what does this concentration of solutions actually mean? Remember, in molarity we have moles per liter, but we have moles of what? The solute. And the solute doesn't always exist in molecular form. For example, if I have 6 molar hydrochloric acid, is there actually 6 moles of HCl in every liter of solution? Well, the truth is there's not, because hydrochloric acid completely ionizes in solution. That means in 6 molar hydrochloric acid, it means there are 6 moles per liter of hydrogen ions and 6 moles per liter of chloride ions, because it completely breaks apart when it dissolves in water. Now, what if we had a substance like sodium sulfate? Of course, in 6 molar sodium sulfate, there are 6 molar concentration of sulfate ions, but the sodium has twice as much as sulfate, right? Na2SO4. So that means it's 12 molar concentration for the sodium ions. So definitely pay attention, and we'll work through some practice problems where you can nail this down. Now let's use molarity as a conversion factor in a T-table. So we're going to start with a 2-liter solution of nitric acid. We want to figure out how many moles of nitric acid there are in that solution if the concentration is 0.2 molar. So start with liters, 2.0 liters of nitric acid. And we're going to change it to moles because a molar, M, means moles over liters. So anytime you see that capital M, I want you to change it. Cross it out and put moles over liters in its place. Got it? So now, where does liters go? On the bottom. So if I have 0.2 molar, that means I have 0.200 moles in every 1 liter of that nitric acid solution. So liters goes on the bottom, and it's always 1. because it's moles per 1 liter. So now multiply. 2 times 0.2 is equal to 0.4. Good. You did not need a calculator for that. If you got your calculator out, then you need to do a facepalm. And I want 2 sig figs, so 0.4 moles of nitric acid. There we go. Put a box around your answer, because that's the way I like it. Let's try another one. If we have 0.3 molar nitric acid, then what volume would we need so that we could have 2 total moles of nitric acid? So 0.3 molar, what's our volume? So we're going to use the molarity as a conversion factor again. Cross out that big M. We're going to write in moles over liters. So let's start with 2.0 moles of nitric acid. Set it up, and I want to set it up so that the crisscross cancels. Moles is going to be on the bottom this time. 1 liter goes on top. Now how many moles are in a liter? Our molarity says 0.30. So we're going to do the top times the top divided by the bottom. So 2 divided by 0.3 gives us 6.67. Well, we better call that 6.7, right? 2 sig figs are allowed, and that's liters of nitric acid. That's how much it takes for you to get 2 moles. Let's do another one. Alright, in this example, we're changing molarity to mass. Well, if we can get to moles, we can get to mass. No big deal. You guys are good at that. So remember, volume times molarity will give you moles. Let's write that down because that's probably your best tip of the day. Volume times molarity equals moles. But I have to have this volume in liters. Move your decimal 3 times over so you can change milliliters to liters. So I have 0.0500 liters of potassium dichromate, and I'm going to multiply that by the molarity. I have 0.360. Molarity is moles per liter, right? Moles per liter. And I'm just going to keep going. Now that I've got moles, how many grams are there in a mole? I don't know. We got to add it up. Potassium dichromate. Let's see. 1 potassium. Okay, now I've got my periodic table handy. So potassium weighs 39, and there's 2 of those. And there's 2 chromiums. Chromium weighs 51.996. And then oxygen, geez, there's 7 of those. And those weigh 16 apiece. All right, so we're going to have to add this up. Calculator time. So 2 potassiums, 2 chromiums, and 7 oxygens. Okay, 294 grams per mole. That's a pretty big substance. Alright, so we put that in our conversion factor. Hey, you know what this looks like to me? This looks like a tea table. Check it out. Multiply the top times the top, divide by the bottom. Get that calculator back out. So I had 294 times 0.36 times 0.0500, and I get 5.292. How many sig figs do we get to keep? Looks like 3. So 5.29 grams of potassium dichromate. Oops, Cr2O7. There we go. So once you get to moles, you can go anywhere else, from moles to grams or moles to molecules or whatever you need to do. Now let's talk about how to prepare a solution. just like we did before, you could figure out how many grams you need, and then of course you're going to weigh out your moles in grams. So first step is to weigh out the mass of your solute. Then I normally have some water in the flask first. This is a volumetric flask. Put some water in first and then stir to get it all to dissolve. And then there's going to be a mark on the neck of that bottle where you fill the water to that mark and fill it exactly to that mark. Don't go past. Remember to read the meniscus from the bottom, so get the water exactly at the right spot, and then you'll have the perfect molarity. So we know that the solute takes up space, right? And the solvent takes up space. So we have to fill it so that together they make a total of 250. You can't add 250 milliliters of water because then together they would take up more space than that. So to prepare a solution, weigh first, dissolve a little bit, and then fill it to the mark. You've got to use a volumetric flask when you're preparing solutions. Well, remember we need moles per liter. So I start with my 4.28 grams, and this is ammonium sulfate, NH42SO4, and we're going to turn this into moles, and then I'm going to show you a little shortcut. Okay, so my molar mass of ammonium sulfate is 132 grams per mole. So now I have moles on top and I want liters on the bottom. I have 300 milliliters, so let's take my milliliters, turn it to liters, and put it on the bottom. So 0.300 liters goes down here. Nothing goes up top because I already have moles here and I have liters down on the bottom, so that's how I want it to look. I don't put anything in this spot. So now get your calculator out. 4.28 divided by 132 times 0.3. And then I have to divide that by 0.3 liters. And now I've got my molarity is 0.108. So I just find it to be easier to put this all in one line on my tea table and not to first do moles and then in the next step do moles divided by liters. I like to combine it into one tea table and just get it all done. If you want to do two steps like we did in example 2, that's fine. Do it however it works for you that you're consistently getting the right answer. Now let's work our way backwards. I have my volume, I have my molarity, I want to get to grams. So I remember volume times molarity is equal to moles. Once I have moles, I can easily get to grams. So I have 0.0500 liters of hydrochloric acid. The molarity is 2.7 moles per liter. So that's 2.7 moles. Remember, big M, write moles over liters. That's moles for every 1 liter. I'm going to keep going in my tea table so that I can include the molar mass, because 1 mole weighs how many grams? Let's see, hydrogen is 1, chlorine is 35.5, so that's 36.45 grams per mole. Now get your calculator and solve your tea table. The top times the top, dividing by the bottom is going to be a piece of cake. 0.050 times 2.7 times the molar mass, 36.45. There it is, 4.92075. And we're going to keep 2 sig figs only. So that's 4.9 grams of hydrochloric acid. So that's how I know to weigh out that many grams of my HCl. Then I dissolve it with some water and I fill to the mark. That's how we make solutions. And now you're going to be a lot better at measuring with solutions. Great. See you guys next time.